Prove that for any positive integer n, the sum of the first n integers is n times n plus 1 over 2. So what we're trying to prove right now is that 1 plus 2 plus all the way up to n equals n times n plus 2. Or sorry, n plus 1 over 2. And we're going to use induction to prove this. And usually mathematical induction, we use that to prove a statement that depends on a positive integer n. And as you can see, n is a positive integer, and we wish to prove a statement. So this hints us to use mathematical induction. So just to briefly recall what induction is, for any statement Sn, we have to prove that first S1 is true for n equals 1. And then we prove that for Sk, that this implies Sk plus 1. So if we can achieve these two steps, then the induction is complete, thus proving the statement. So we're just going to start with the first step right here. The first step tells us to prove the statement when n equals 1. So when n equals 1, we know that 1 equals 1 times 2, which is 1 plus 1 over 2. And 1 equals 1, so this is true. And our second step tells us to imply that when n equals k, such that 1 plus 2 plus all the way up to k equals k times k plus 1 over 2. We assume this is true, which is called the inductive hypothesis. And we try to prove that when n equals k plus 1, 1 plus 2 plus k plus 1 equals k plus 1 times k plus 2 over 2 is true. So we use these two to do the induction. So let's take the left side for our third statement right here. Let's take the left side and rewrite that as 1 plus 2 plus k plus 1. And from our inductive hypothesis, which is the second statement right here, we know that 1 plus 2 plus all the way up to k is k times k plus 1 over 2. So we can rewrite this part as k times k plus 1 over 2. So let's just simplify this expression right here. We can simplify this as k times k plus 1 over 2 plus k plus 1. Simplifying that, we get common denominators 2, k times k plus 1 plus 2 times k plus 1. Well, k plus 1 is a common factor in both expressions, so we can factor that out, which makes it k plus 1 times k plus 2, and all over 2. So this is a result we got for the left-hand side right here. So we know that this left-hand side equals this, but this also equals the right-hand side. So we prove that for n, when n equals k is true, n equals k plus 1 is also true, which completes the induction. So therefore, our original claim in the problem, that for any positive integer n, the sum of the first n integers is this, is also true.